Okay, this is a video on 8.1, starting chapter 8 with quadrilaterals. 8.1 is about finding angle measurements in polygons. Before we jump into new information, quick review of what a polygon is. It's a closed two-dimensional figure made of line segments. So it does not have any curves and it doesn't have any openings as if it was a fence that something could get out. Two-dimensional rather than three-dimensional. Two-dimensional is something like a square or a triangle. Three-dimensional would be something like a cube or a rectangular prism. We're talking only two dimensions in this section. There is a difference between two different kinds of polygons, the convex polygon and the concave polygon. The convex polygon, if you extend any of these lines, it will not go through the middle of the figure. A concave polygon, if you extend any of the lines, one of them might go through the middle. Concave does exist. Of course, convex also, but convex is what we're going to be concentrating on in this chapter. New theorem, the interior angles theorem. Know the difference between an interior angle and an exterior angle. If I have a basic figure, this is an inside angle, this would be an outside angle. So know the difference between the two. This theorem talks about the inside angle. So the sum of the measures of the interior angles of a convex n-gon. Convex is what I had just explained. N-gon is a generic term for a polygon. It means some number and it is a polygon. So a 5-sided polygon or a 10-sided polygon. The formula to find the sum of all those angles, you take the number of angles, subtract 2 and multiply by 180. That gives you the sum of all the interior angles. Like any formula, you have to know this no matter if they give you the number of angles or if they give you the total sum. You have to work either way with that. And these should be reviewed. These are all the names of different polygons. I'd like you to know quadrilateral, 4-sided, up to dodecagon, which is 12-sided. Most of these you should already know, but if you don't, I'd like you to memorize these. Past 12, we're going to call them n-gons. So if it was a 13-sided figure, we would call it a 13-gon, or an 18-sided figure would be called 18-gon. The generic terms are okay. There are specific terms if you Google it, but we're not going to memorize anything past 12. Also know that these are names. For example, pentagon is a 5-sided polygon. Because it's a pentagon does not necessarily mean that it is a regular pentagon. It just means that it's a 5-sided pentagon. If it was a regular pentagon, that would mean that all the sides and all the angles are the same. This is a generic term for a 5-sided polygon. And when I just mentioned a regular polygon, all the sides have the same length, all the angles have the same measure. That should be review. First example, find the sum of the measures of the interior angles of a convex polygon. So this is an 11-gon, so this is an 11-sided polygon. We're plugging it into our formula. Remember, it's n minus 2 times 180. The number of sides is 11. 11 minus 2 gives me 9. 9 times 180, the sum of all the inside angles is 1,620 degrees. Pretty simple example. The next example is we work backwards. It says the sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. Classify, that means to name it. Give it a name using one of the names that I just showed you a minute ago. So we know the sum is 900. The inside angles all add up to 900. I'm using the formula that we just talked about a minute ago. N minus 2 times 180 gives me 900 because that n tells me how many sides it has, which will allow me to name it. I'm going to divide both sides by 180 first. Then I'm going to add 2 to both sides, and this tells me that it's a 7-sided polygon, which is called a heptagon. So a heptagon is what we were looking to find. Here's another example. The sum of all the inside angles is 2,520. We're plugging it into the formula. We know the sum is 2,520. We're trying to figure out how many sides it has. Divide by 180 first. Add 2 to both sides. We know that it has 16 sides. So we can call it a 16-gon. Remember, if it's anything bigger than 12, we're calling it that number gon. Another example, finding the value of x. These problems are more than one step. We need to figure out what all of these inside angles add up to be. So we're going to use that formula we just talked about. It has 5 sides to it. So we did 5 minus 2 times 180, and that gives me a sum of 540. So when I add all of these angles up, it adds to 540. So I added 64, 2x, 110, 86, and 3x and got 540. Pretty simple equation to solve x is 56. But this is important to know because you can't set up your equation without it. One more key idea, polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex polygon is 360. This one's an easy one to remember because it's always 360. If you look at my example here, the exterior angles are formed by extending that side length. So all of these exterior angles of this polygon are going to add up to 360. That's where my equation comes from here. Again, pretty simple equation to solve. Simplify and x equals 9, which is what we're looking for. But again, you need to know that the exterior angles add to 360, and that's something that you'll need to memorize. Here's your homework on 8.1, and as always, you'll have a quiz on 8.1 next block.